So GKE is a managed Kubernetes service. The fleet is where we manage the Kubernetes master and nodes at scale for you. And it's where we invest lots of time and thinking to abstract away the complexity and variety of options the framework offers to you, so you can focus on your workloads, your business application. As you can probably know, the open source community is super engaged. It drives lots of code changes and improvement. And as you can see on this slide, I have some data here from a presentation that was given last year at KubeCon. You can see the amount of add-ons, repositories, and code changes that we need to manage when we think about managing Kubernetes clusters for you in the fleet. Our goal with GKE is actually streamline and simplify the management for your cluster and provide a hassle-free service. This means non-disruptive and continuous service that supports your business through low and high demand periods or seasons. I guess there are different market segments or market verticals that I could use for example here, but this one evidently shows you the reliability we deliver by GKE to retailer customers specifically, during a very high-peaked season, Black Friday and Cyber Monday. Among these customers, we have Loblaw, which I mentioned before, Canada's largest retailer, and I'm really excited to have Justin here, and he will share with you more about their experience later in the session. So next, let's dive into kind of the mechanics of managing a fleet and what controls you have. Kate here will walk you through some of live demos and show you tools and capabilities you can use today to manage disruption and risk.
So basically, my job as an engineer on GKE infrastructure is kind of like twofold. First, ensure reliability for the product, but also make sure that it's easy to maintain. And on the intersection of those two different dimensions is actually the upgrade story. Because as you know, we're on a fleet of 1,000 clusters. And one interesting aspect of running hosted Kubernetes is that there are versions. As you know, we move the master version regularly. However, the upgrade of the nodes is under your customer control. So how do we deal with that situation? Because when the gap between the control plane and the client grows, you might run into incompatibility. One solution here is to have node out upgrades, and we have such a feature. However, rarely or not as often as we would like, people use it. And why is that? Because it's hard to give control up. And that is because upgrades bring workload disruption. And while we try to manage that workload disruption, that is the reality of it. Upgrades bring disruption. And even though our fleet is different in shape and sizes, it's even harder to upgrade smaller clusters, smaller node pools, because you don't have extra capacity that can cover the disruption period. So what actually happens behind the scenes when you upgrade a cluster? Node by node, we drain a node, we recreate a VM, we wait for that VM to run, to become running. And then we wait for the node to be registered with the master and become ready. And then the workload is resumed. So this is the period where your business might experience some disruption. How can we make this better? Well, if you look at that timeline, you can see that there are certain things that we can move out from the rescheduling part. And specifically, we can create an extra VM, also called surge VM, before draining the node. And you can see how disruption period actually shortens, and it equals now only the time that it requires Kubernetes to reschedule your workload from node to node. We call this feature surge upgrades. We're going to launch it in alpha this quarter. You're welcome to use it. But what exactly it means for your workload? Well, I cannot look inside of your application, but what I can do is that I can create a simple demo app that is a little bit more sophisticated than a stateless thing. There is a state here. There is a storage that I read and write into. On each of the graphs, the upper line is the queries per second or requests per second for reads and writes, and the lower line is the error rate. So the upper half of the graph is actually what happens to the workload when we do the regular upgrades as we do them right now. Kill a node, let it come up. You can see that there are dips in the traffic as well as spikes in the errors. The lower half of the screen shows you the same app running on a similar cluster, 3 nodes, but during the surge upgrades. You can see that dips are more shallow, and also the errors are not that frequent. But even that kind of like proves that there is only so much magic that we can do for you in order to make sure that your application is reliable. There is still, it's not a silver bullet solution. There is still some things that you can do as a customer. And this is where I would like to take my Google hat off and just talk about what workload disruptions are and what you can do to protect yourselves against it. So let's take a look at my simple app. I'm running 3 nodes, which is the default size on GKE, as you know. It's not too much, it's not too little. It's exactly what you need to run some sufficient workload. As you can guess from the names of those 2 pods, I'm running Redis. It's an implementation detail. I'm not telling you that you should run Redis. That's just to show you that there is some state. And to make things a little bit more interesting, I actually have a persistent volume connected to that Redis. So what happens here? The client attempts to perform writes and reads. And let's take a look at the code so that I'm not just telling you something. All you need to know is that I initiate the client, I have the connection to Redis, and then I attempt a write, and if it succeeds, I report it. If it doesn't, I also report it. And then I read. And that's it. That's all I have in my simple demo app. So let's take a look at the logs. So there's some reads and writes happening. When we upgrade a node, we take it down, and that means that we actually kill your pod, right? And that means that at a certain point, your application starts serving errors. Of course, Kubernetes reschedules the pod and the situation recovers. However, there is a period during which you serve errors. If we delete the client itself, as you can guess, it's going to be even worse. You will stop serving traffic altogether. So you have no connection to the customer altogether. What can you do to amend that? Let's not talk about Redis for a second here. Let's talk only about the client. One of the obvious things to do here is just to increase the number of replicas that you have. And let's just make sure that we know what is happening behind the scenes. So we had one, let's say 3. 3 is a good number. So we see that now immediately we have 3 apps, 3 pods scheduled and running. But what is actually, where are they running? Well, turns out that they all got scheduled on 3 different nodes, on 2 nodes. 2 of the nodes where the 3 replicas got scheduled are the same, which means that when we attempt to upgrade that particular node, you will still lose 2/3 of your capacity, of your serving capacity. So that's still not good enough. What can we do to amend that? What we can do is that we can tell the scheduler, hey, by the way, I know what I'm doing, and try to schedule those particular replicas on different nodes, which is to say we plan to use pod anti-affinity. Let's add that. And we can see that immediately the scheduler obeyed our request and reschedule the pod so that we have them evenly distributed across the nodes, so that we can rely on at least 2/3 of the client capacity always be available during an upgrade. So if you don't remember anything from this talk today, just take this back with you. Redundancy. Redundancy is important. There are many things that we can do for you at Google, but you have to take care of yourself by providing yourself a little bit of slack. What specifically it means? If you have no idea what you're doing, that's OK. Just remember the simplest formula possible that SRE love, n+1. Just give yourself some breathing room. But not only give it, but also use it. You can think about your application as different fault domains that you want to separate and run separately of each other so that if part of your application fails, the other one still can survive and serve some traffic. However, is that good enough if we have redundancy? Let's take a look. So I have prepared a different cluster, which is a little bit more. And what I have here is I have many more nodes. I have 9 nodes in total. I also have 3 replicas of a client, as we saw earlier. I added them. But here, I also have 6 replicas of Redis, which are configured to be a cluster. If you don't know what a Redis cluster is, it doesn't matter. What you have to think about it is there is enough redundancy. There are 3 masters, 3 slaves, and they are connected in such a way that if you lose, there's a certain threshold. If you lose certain capacity, you're still good to go. But is that good enough? Let's see. So let's say I was working on a script, and I just forgot what I was doing, so I just want to run it to see what was happening. Turns out I was working on a script to drain a cluster. However, I left it midway, and as you can see, I actually caused a total outage. I cordoned all the nodes, and I also removed all the pods, evicted all the pods from those nodes. Let me quickly restore that so that we can continue with the demo. So, which means that redundancy that we had didn't save us. In a matter of seconds, I created a total outage. And that can be, a human error or a mistake, an honest mistake. What can you do to protect yourself against that? And again, Kubernetes is such a huge universe that there are many, many mechanisms. But the simplest thing you can do is you can add the pod disruption budget. And pod disruption budget is a place where you say, OK, these are the pods that I want to protect, and this is the rule that I want to apply to the particular deployment or stateful set or whatever you have. For instance, max unavailable can be only 1. At a time, there should be only 1 pod unavailable. Or similarly, just to show off what pod disruption budget has, you can also specify mean available. How many at a time should be available in contrary? Let's apply those two. So we now have those two in place, and we have actually our application restored and running. And you can see that PDB says that there is allowed disruption of pod number 1 for each of those deployments that I have. So what happens if I will try to just drain everything again? Well, this is already, looks like good news. I have messages coming back that cannot evict a pod. And that's because the scheduler knows that I have a certain rules in place as to how many replicas should be running at a time. And you can see that, yes, I managed to kind of get rid of 1 pod in each stateful set and deployment, and I also managed to cordon the nodes, but there is no total outage. We're still serving traffic. We're still OK for the time when we try to recover. So redundancy is not enough. You have to put in place some protection if you are extra paranoid. And that's right to be extra paranoid. Additionally, there will be no demo, but additionally, you can also help us to help you by providing a little bit more detail of what exactly you're running in your black box. And specifically, you can use the readiness probe and the liveness probe, two things that I used during the Kubernetes lifecycle that help us understand, is your application ready to receive traffic? And that's readiness probe. Or is your application healthy enough? And that's the liveness probe. If not, let's restart. In case of a Redis that I was using, those particular things would be just pinging the via Redis CLI to make sure that the instances are available. So with those three in place, let's take a look what happened to that demo app that I had. This is just to remind you how the graphs looked before, and this is after the app was tuned. So even with the current upgrade mode that we have, when we have to kill a VM at a time, you're still already doing much better. With surge upgrades, you're almost golden, but there will be no magic in this world, so you will have disruption at any point of upgrades. You just have to accept it as price for staying up to date. And just a couple of words of things that you should not be doing. One of them is specify min max unavailable 0 or min available equals to the number of replicas that you're running. Because for us, it's just a hard stop. We cannot do anything because the scheduler will refuse to drain a node where we have one of your pods running. Similarly, you should be careful about the liveness probe because if the liveness probe that you define does not sustain a load and it will fail, that means that Kubernetes will think that the application is unhealthy and reschedule it, which means there's cascading failure if you already are experiencing a severe load. In the same manner, termination grace period should be something meaningful. It cannot be 0, which means that we don't wait whatsoever, or it cannot be hours when we have to just wait hours. And with that, I would like to hand over to Justin.
I'm here from Loblaw, and we are Canada's largest retailer, and it's interesting to think about that. Canada is like the second largest, North America's second largest land mass. There's only like 33 million people that live there, and so it's crazy to think that it's like 85% of Canadians shop in one of our locations every week, right? And so that's a whole lot of trust that our country places in us, and it's a really deep customer relationship. And so as a result, our mission is pretty big, right? We want to help Canadians live life well. And so for me at Loblaw Digital, my goal is to do that in the lens of cloud native. And so I'm really humbled to work and run a team called Engineering Productivity. And for us, our mission is to reduce toil, increase happiness, and get shit done. Right? And it's the confluence of trying to have the philosophies of DevOps and of SRE and of shift left, and thinking about how we enable engineers to solve problems rather than hiring people to verify if engineers solve those problems, right? It's all about enablement. And what we really love is that in Kubernetes, we're able to bring that conversation together. And the great demos that you just saw, that manifest YAML, whether it's actually how we deploy the application, scale the application, adding liveliness and readiness checks, you would have SREs editing that. You would have DevOps engineers editing that. Heck, you should have QAs or anyone in your organization actually looking and understanding what that is. That's your source of truth, right? Everything is code. And so overall, the fundamental goal we have is to operate at the intersection of innovation and stability. And what's funny is I was thinking about this today. Loblaw is actually a 100-year-old company. And I think about, what we're doing in Kubernetes and thinking about managing load and resiliency. And there's this really interesting tidbit I know from our Wikipedia page. We actually invented the shopping aisle in like the late 1800s. And before then, if you look at like old movies, there was a dude behind a counter and he would grab your stuff and give it to you, right? Like the max number of customers you could serve is 1. A redundancy factor of 1. If he didn't make it to work, like nothing could happen. And the idea of the shopping idea, right, is it's that innovation of what if we could actually serve more customers and they could serve themselves and make their lives better. And it's interesting being in retail where we have the ability to impact not only technology, but what's happening in the real world with our customers, right? And it's not always in the data center that those wins are happening. It's sometimes actually in the physical world. And so it's just been really interesting to see how that same message carries on through 100 years. So specifically, what I'd really like to talk to you about today, it's a very thin sliver of what we do, but it's about how GKE has really made our lives easier. In 2018, one thing that was really great for us was it was the first year that we had a Black Friday and Cyber Monday where none of our systems crashed. And even more impressive for us was that we actually maintained our SLA for response time and error rate throughout. And that's just really thanks to Google and that mission. It's the first year we've been running entirely natively in GCP, and we're really proud of that accomplishment. And so it's great to focus on error rate, it's great to focus on response rate and just be up. But for me and my team, like I said, it's engineering productivity. It's about getting things done faster. It's about reducing toil. It's about increasing happiness. And something that's really, really toilful is upgrades, right? Coming from Canada's largest retailer, running, I believe, the largest data center in the country. We have 2 of them, a PR and a DR. Upgrades are a nightmare, right? They take an entire team of people, a very concerted effort to think about how are we keeping our packages up to date, our operating systems up to date, and our servers up to date. And so when we saw the ability to use the functionality of auto upgrades, we were there. Because we didn't want that to have to be a burden that our team took on. And so auto upgrades have 3 main benefits, right? Security, reliability, and functionality. And a great example, if you all know the run C violation that recently came out, it's a really serious CVE. By the time we knew about it, we were already safe, right? And that's thanks to the great work that the Google team are doing to keep the masters. And actually, in that case, it was Container OS didn't even have the flaw. And there's another one, there was a privilege escalation CVE that happened late last year, and that was actually having those auto upgrades on. Before we found out about it, we were already safe. And so from a security perspective, it seems like a no-brainer. But something that Kate did a great job of highlighting is that work disruption can be a really serious issue, right? And so we love automation. We love magic. But sometimes later can be safer than now. And I'll give you a kind of a good example as to why. If I'm in retail, when I upgrade is actually really important. If we are in the middle of Black Friday, or if it's even a Thursday, because Thursday is when we launch our promotions, I probably don't want to run that risk of having a disruption happen. Because in the best case, we get the really nice graph that Kate showed. In the worst case, that graph's a whole lot nastier. And so today, right, opting into auto upgrades, I feel great, toil's reduced, but I don't have quite enough control. Today, Google allow you to set a 4-hour window of when they should do their upgrades, but there's a couple things that doesn't account for, unfortunately. One thing it doesn't account for is the day of the week to do that upgrade, and for that, that's important to us. And the second is the calendar year, like thinking ahead. We know when our big milestones are, and for retail, obviously, once again, Black Friday and Cyber Monday, those 2 are gonna come up. Please don't touch our infrastructure around these times. Or if you're working in a company that has code freezes, right, for holidays or vacations where you don't have staff on hand, that's really important. So some of you might not be opting into auto upgrades because you don't have that control. We've taken the risk, and for us, reducing the toil of having to do it ourselves was worth the potential risk of it going wrong and us having to be there at an odd time. And then the other one is about how you upgrade. Right now, it's an all or nothing approach, and when we do it, Google does it node by node today. And what we've noticed is that we're running a multi-tenant, multi-cluster, and a multi-regional cluster at that. At Loblaw, one interesting thing is we believe that all of our businesses are good neighbors, and that allows us to invest in something we call soft multi-tenancy, right? We don't have to have the strict isolation because there's an implicit trust between, let's say, Joe Fresh, which is our retailing clothing brand, and Shoppers Drug Mart, where we're doing beauty products and pharmacy. And we actually might want to make that a really strong connection because they may have services that talk to each other, like their shared communal login, which is our PCID application. And so for us, multi-cluster has been really important. But when we do an upgrade, right, when we're exposing that auto upgrade and that's going node by node, we're actually impacting a lot of our businesses. And so one feature that we've really loved is this idea of node pools. And node pools, you can actually have it so that an upgrade happens in a specific node pool. And so we definitely recommend not just using the default node pool, right? And whether you're t-shirt sizing, small, medium, or large for certain workloads, or doing it per business, that kind of gives you an ability to break up your upgrades and make sure they're safe in one place before moving on. The second thing that we've seen is the what are we upgrading, right? And for those of you today, like there's a lot of Kubernetes versions, right? And it's moving extremely quickly. And whether it's patch, whether it's major, whether it's minor, for us, when we're auto upgrading, we feel good about that we're getting new security updates, but we're not quite sure what else is coming. And so I feel like I'm sleeping safer at night, but I don't know what to tell my engineers they now have access to. And we felt like we didn't really have enough control at times to understand what channel we're even on, like that bleeding edge of alpha versus beta versus stable. And so we're hoping that we can see some more control in those areas. But at the same time, from a productivity perspective, we're really thankful that we can upgrade very quickly. And so overall, later can sometimes be safer than now. I would suggest that everyone that cares about these upgrades and their own sanity get off the manual train and into auto, and by doing so, get the feedback to Google for how automatic upgrades can be made better. And I think overall, we will be in a better place if we're focused on engineering. As a retailer, we want to sell groceries. I really don't want to be in the business of managing operating systems, managing upgrades, and having to staff people for that. And at the end of the day, the people that we staff to do that, I don't know if anyone was born with the idea that, like, my big dream in life is to upgrade operating systems. Like, operations engineers, like, we have big ideas and big dreams. And when I look about the amazing features that Kate's showing off, like, that's what we want our engineers to be doing, right? And so I think we should aim higher in that regard for the type of work we're doing and the impact that we're having in our organizations. So, overall, we're really excited by these new features that are coming out. We're heavily invested in this from the Loblaw digital side. And I'll hand it back to Kobi to see what's coming next.
Thank you, Justin. So far we spoke about challenges, we saw some amazing demos, and we heard from Justin about their experience. Next, I'm excited to share with you some of the new capabilities we are working on to actually provide you with even more control and flexibility. We'll be focusing on 3 areas: reduce risk, control disruption, and manage risk. Let's talk about the first one, how you can reduce risk. And Kate mentioned it before. So we are actually changing the way we will be upgrading nodes in clusters managed by GKE. Right now, the way we upgrade nodes is at the time of the upgrade, we'll go one node after the other, and we'll remove that node and bring a new one with the new version. That's obviously slightly disruptive for customers, and we are changing that process with Surge Upgrade. So with Surge Upgrade, we'll actually create a new node first, and then we'll gracefully drain the old one, and at that time, we'll remove the old node. What that gives you is a few things. One, it allows us to secure resources before we even start upgrades, because we create that node before we take the old one down. The second thing is we ensure successful completion of the node upgrade. We protect your customer, your capacity, right? So at any given point of time, you have the number of nodes you expect to have even during upgrades. And that in turn reduces disruption and reduces downtime. Justin mentioned the maintenance windows support we have today. So yes, you can create maintenance windows, and we will respect that. Basically, the feature that we have right now supports 4 hours maintenance windows in any given day. So obviously, there's less flexibility right now. Next, we are actually going to enhance the maintenance windows capabilities to support different use cases, like the use case that Justin mentioned. So let's say you prefer to avoid upgrades during weekends because you are a gaming company and most of the traffic is coming in through the weekends. You'll be able to do that with the enhanced maintenance support, maintenance window support. If you are a retailer and you are trying to avoid completely any maintenance events during Black Friday, Cyber Monday, you will be able to specify the range of dates, and we will respect that and avoid the upgrades during those times. And then lastly, you know about upcoming upgrade, but you just need more time. You need more time to prepare, or you have some internal challenges that you're facing. You'll be able to postpone or snooze an upgrade for a short period of time. That gives you more flexibility in controlling disruption. The other way to control disruption is really our release notes, and transparency is really key for us. In the release notes, you get much more information than just the change log. You'll get information about the upcoming release schedule, the releases that we are deprecating, the releases that we are going to make available. And the other thing is, we have a 4 days rollout policy in GKE. So we roll out new version in different regions during 4 days. You can actually see that schedule in the release notes. So we are publishing what version is coming first in which region, and you can actually plan your upgrade accordingly. Let's talk about managing risk. We spoke about ways to manage risk, and I think PDB or pod disruption budget is super important capability that we support today, especially if you have a stateful application. But in order to support your risk mitigation, Canary Cluster will allow you to create a cluster and designate it for Canary or staging environment. That in turn will indicate to us that we should roll out new versions to those Canary cluster before we roll them out to your production clusters. So there will be kind of a mapping between your Canary clusters and your production clusters. So we'll roll out new version, we'll give you enough time to run your automate tests, to get some confidence, and when you green light the version, we'll continue rolling out the upgrade to production as well. And another exciting feature in Q2 is release channels. We spoke about the amount of versions we support, and it's really overwhelming. And we are trying to make it easier for customer and move away from that structure of supporting many, many versions to supporting 3 channels. We are thinking right now about rapid, regular, and stable. So if you want to get early access to the latest and greatest bleeding edge version of Kubernetes, you probably want to be on the rapid channel. And let's say you have a testing environment, you will be able to say, hey, this is my testing clusters, and I want to subscribe this cluster to the rapid channel. We'll make sure to roll out new bleeding edge versions in that specific cluster. Same thing with regular and stable. Regular will give you the default version, like the one we have today available in the fleet. And stable, you will probably get less features, but it will be more stable in terms of more, the version accumulate more soak time, and we have more test coverage for that specific channel. Just a quick example of how this may look like from a command line perspective. So you can create a new cluster and subscribe it to the rapid channel. So we spoke about different and many great features, and I just want to take a moment to kind of bring it all together. Our goal is to keep your cluster up and running and deliver non-disruptive experience, even during upgrades. And visibility is key for us, as I mentioned before. We want to make sure that you understand our product lifecycle and you can plan accordingly. We aim to provide hassle-free managed Kubernetes service so you can focus on what you care about and your core business. If you are interested in any one of the features that I mentioned today, please follow this link and you can sign up and share with us your interest in joining the alpha program for one of these features.